Have you ever wondered where it all started? How our home, Earth, came to be? Let's go back, way back, to the very beginning. Picture this: the universe, a gigantic, seemingly endless void. Then, about 14 billion years ago, a singular event of staggering proportions happened: the Big Bang. In less than a blink of an eye, the universe expanded from a tiny, hot, and dense point into the vast space we know today. In this cosmic soup, tiny particles started to come together, forming atoms, then molecules. These molecules, in turn, formed the first stars and galaxies. The universe was a stage set for a grand performance, and Earth was about to make its debut. Fast forward a bit, to about 4.5 billion years ago. Our solar system was but a cloud of dust and gas. But within this cloud, something extraordinary was happening. Particles started to stick together, forming clumps. These clumps grew bigger and bigger, attracting more and more material through their gravity. Over time, these clumps became planetesimals, the building blocks of planets. One of these planetesimals, through countless collisions and accretions, eventually became Earth. But the early Earth was nothing like the planet we know today. It was a hellish world, covered in molten rock, bombarded by meteorites, and devoid of any life. This was the Hadean Eon, the first geological era of our planet. But even in these violent beginnings, the first steps towards life as we know it were being taken. The heavy meteorite bombardment brought with it water and other essential elements for life. Volcanic activity released gases into the atmosphere, creating the first weather and, eventually, the first oceans. And thus, from the chaos of the cosmos, our blue planet was born. A planet that, against all odds, would become a haven for life in the vast expanse of the universe. But that's a story for another time. For now, let's marvel at the extraordinary journey our Earth has taken, from a cloud of cosmic dust to the vibrant living world we call home. Imagine a world without oxygen. Sounds impossible, doesn't it? Yet that was how Earth began. In those early days, the atmosphere was a lethal cocktail of methane, ammonia, and other harsh chemicals. But then, a plot twist occurred, a twist that would forever change the course of life on Earth: the rise of cyanobacteria. These tiny, single-celled organisms, invisible to the naked eye, were the unassuming heroes of our story. They had a special skill: photosynthesis, a process by which they converted sunlight, water, and carbon dioxide into food and, crucially, oxygen. In their millions and billions, these cyanobacteria worked tirelessly, day in, day out, for millions of years. Their hard work slowly started to pay off. The oxygen they produced began to accumulate in the atmosphere, marking the beginning of what we now call the Great Oxidation event. This event, which started around 2.4 billion years ago, was not an overnight sensation. It was a slow, steady process that took nearly a billion years to complete. During this time, oxygen levels rose from virtually zero to about 21% of the Earth's atmosphere, the level we enjoy today. But the Great Oxidation was not without its drama. The new oxygen-rich atmosphere was toxic to many of the Earth's earliest life forms, leading to a mass extinction of anaerobic organisms. It was a tumultuous time, a time of great change and adaptation. Yet, as the dust settled, a new world emerged. The oxygenated atmosphere made possible the evolution of oxygen-breathing life forms, including, eventually, US humans. It paved the way for the development of complex life and biodiversity as we know it. So the next time you take a deep breath, remember the cyanobacteria. These tiny organisms transformed our planet, turning a hostile alien world into a home fit for life. The stage was set for more complex life forms to emerge. Life on Earth has not always been a smooth journey. It has faced extinction, not once but 5 times. Each of these mass extinctions has its own story, its own causes, and its own effects. Let's start with the Ordovician-Silurian extinction, the first mass extinction. Around 444 million years ago, glaciers formed, sea levels dropped, and the majority of life, which was in the sea at that time, disappeared. The most affected were the brachiopods and bryozoans. Next, we have the late Devonian extinction. About 375 million years ago, the Earth experienced a prolonged period of climate change. The oceans were the hardest hit, with many species of fish and other marine life wiped out. Then came the mother of all mass extinctions, the Permian extinction, often referred to as the Great Dying. Occurring roughly 252 million years ago, It's estimated that over 90% of all life on Earth was eradicated. The cause? Scientists believe it was a combination of volcanic eruptions and the release of methane from the ocean floor. The fourth mass extinction, the Triassic-Jurassic, occurred around 200 million years ago. It paved the way for the dinosaurs to dominate as many other reptiles and amphibians did not survive. Lastly, we have the Cretaceous-Paleogene extinction, the one that famously wiped out the dinosaurs. This happened 66 million years ago, and the most probable cause was a massive asteroid or comet strike. Each of these extinctions had profound effects on life on Earth, reshuffling ecosystems and paving the way for new species to evolve. But what's remarkable is that life, time and time again, has shown its resilience. Each time, life has bounced back, evolving into new forms and species. Now imagine a world covered in ice. That's what Earth looked like during the Ice Ages. Let's take a step back into the Pleistocene epoch, a period that spanned from about 2.5 million years ago to almost 12,000 years ago. This era was marked by repeated glacial cycles, also known as ice ages. Think of the ice ages as Earth's freezers, turning a substantial part of the planet into a vast, frosty wilderness. These were not just one-off events, but rather a series of deep freezes that occurred over millions of years. Each cycle consisted of a glacial period, where ice sheets expanded across continents, followed by an interglacial period, where the ice retreated and temperatures rose. So, how did these ice ages shape the planet's geography and climate? Well, during glacial periods, the advancing ice sheets carved out valleys and mountains, and as they melted during the interglacial periods, they left behind lakes and other bodies of water. The Great Lakes in North America, for instance, are remnants of the last ice age. The climate also underwent dramatic changes. As the ice advanced and retreated, it affected global temperature patterns and wind systems. This in turn influenced rainfall distribution and the types of vegetation that could grow in different regions. And it wasn't just the land that was impacted. The oceans also felt the chill. Sea levels dropped as water was locked up in the ice, and the colder temperatures affected marine life, leading to evolutionary adaptations in numerous species. But the ice ages also had a significant impact on human evolution. The changing climates and landscapes forced our ancestors to adapt, to innovate, and ultimately, to thrive. While the ice ages may seem like a frosty chapter in Earth's history, they played a pivotal role in shaping the world as we know it. They sculpted landscapes, influenced climates, and even impacted the evolution of life itself, including our own. These cold periods have left an indelible mark on the Earth as we know it. From the Big Bang to the present day, Earth has been through an incredible journey. This voyage, spanning billions of years, saw the formation of our planet from cosmic dust, the Great Oxidation event that breathed life into lifeless matter, the 5 mass extinctions that reshaped biodiversity, and the ice ages that sculpted the world as we know it. We've traveled through time, witnessing the Earth's evolution, its resilience, and its tenacity. Now we stand here in the present, the Earth beneath our feet, the sky above us, life teeming around us. But it's not the same Earth as it was billions of years ago, is it? Today we find ourselves facing challenges that threaten to alter the course of our planet's history. Climate change, the invisible yet formidable beast, is causing rising sea levels, extreme weather events, and shifting ecosystems. The polar ice caps are melting, our forests are burning, and our cities are choking with pollution. And then there's biodiversity loss. We're losing species at an alarming rate, a mass extinction in the making. As habitats shrink and environments change, the intricate web of life is being torn apart. So where does this leave us? Well, we're not mere spectators in this grand spectacle of Earth's history. We are active players, and our actions today will shape the world of tomorrow. But there's hope. We're not helpless. We have the knowledge, the tools, and the power to make a difference. We can reduce our carbon footprint, protect our ecosystems, and fight for policies that prioritize the planet. We can educate ourselves and others about the importance of biodiversity and the impacts of climate change. Each one of us holds a piece of Earth's future in our hands. With every decision we make, every action we take, we're writing the next chapter in Earth's history. It's up to us to write the next chapter in Earth's history. What will it be?